Thank you for opportunity to present our work at Linaro Connect. Radek and I represent AArch64 on Windows ecosystem team. We contribute to improvement for developers who want to deploy their applications on Windows AArch64. We have a couple projects which we are working on. One of them is PyTorch, bringing AArch64 support for PyTorch. Also, we are working on cloud adoption. We're trying to migrate and provide our expertise on migration from x64 infrastructure and cloud and Azure to AArch64. Also, we're working on WebAssembly, providing our expertise to bring WebAssembly to Visual Studio. Actually, this is what happened last year. And we are working on bringing some optimization to OpenSSL and some other libraries. One of the projects which we are also contributing is Git for Windows. As you can see here, there's many logos of different packages and technologies which are used there, and we will go during this presentation deeply and what actually we're doing with those technologies and packages. So our main interest is porting Unix application to Windows, and the main approach to port Unix application to Windows is identify dependencies. You need to figure out, okay, there is those libraries present on AArch64. If they're not present, how you can build them. Then you can look also in the code base and check, okay, there is some platform-specific code which should be rewritten, and there is some assembly code which can be disabled. So in most cases, assembly code brings mostly optimization, and maybe you don't need to really focus on that in the beginning, but in some cases, it's a must also to rewrite that code in the beginning of the journey. And of course, you need to have tools which can help you to build your application on new platform, on your architecture. So one of the way how you can build Windows application which was originally developed for Unix platform, it's using MinchW. So it's minimalistic GNU Toolchain, which was developed for Windows. And there's a couple ways how you can use MinchW. So first way, you can use it on Windows directly. For that case, you need environment, like Bash and other components there. So for that reason, you can use MSYS2, which brings that experience to Windows, and you can install MinchW and build your application on Windows by using MSYS2 and GNU Toolchain. Another way, you can do cross-compilation, the same way you are installing MinchW and building your application on Linux, and then you're executing that application on Windows. So in case of MinchW, if you have any platform-specific code there, so it should be rewritten, because MinchW brings mostly direct connection to Windows API. And if you have some POSIX stuff there, so it will not be really working there immediately. For that purpose, there's another way how you can port your application to Windows. It's using Cygwin, which introduces POSIX experience on Windows. So you can take just your Unix application. In most cases, you don't need to rebuild anything there. Not rebuild, but rewrite anything there, and it will be just compiled as it is with Cygwin. Definitely, it's advantage there, but you need also to have Cygwin ported to that architecture. So this is like two ways how you can bring applications to Windows from Unix environment. And if we're looking at dependencies which we have for Git for Windows, we can see that we have MSYS2, we have Cygwin, we have MinchW, and both of those packages, they don't present in ARC64. So actually you need to build those packages for ARC64, which is okay, let's build them. But if we're trying to find tools, we see that actually we don't have tools how we can build those packages. The way how they should be built, the classic way, you need to use GNU Toolchain. And we need to add new target to GNU Toolchain first. And actually it opens two big streams of work which we are working on. So first, to add new target that we will be able to build those packages for ARC64, and also porting Cygwin to ARC64. So I will talk more about adding new target to GNU Toolchain. So for GNU Toolchain, there is like free repos we are using. So we're using binutils and GCC as part of GNU Toolchain, and we're bringing our target. We're bringing the ARC64 target there. And also we need to bring new target to MinGW, which provides us runtime. So here you can see the name for new target. Maybe it's a bit complicated to understand for what every word stands there. So this architecture is quite clear. It brings ARC64, W64, it represents Windows 64-bit, and MinGW32 represents MinGW, which was originally developed for 32-bit, and later it was extended to 64-bit, but the naming stayed the same. So the first step for us was to bring new target to binutils, to compile some simple hello world application for ARC64 using just assembly code. And we started this journey with the binutils. There was a lot of work with the relocations which should be introduced in binutils for new architecture. A lot of reverse engineering for COF format, for P executables, portable executables. Somehow it's not very well documented, and you need to really do reverse engineering of existing executables to see how relocation tables should look like in segments and many other work. So once it's done, we had to also resolve issues with the linking for ARC64. And after that, we were able to write some simple hello world assembly code, which was used by binutils to create executable and was running on ARC64. And it was a good moment to start contribution to binutils upstream. And at the same moment, it triggered also interest from the community, and they started working in parallel also on adding this target to binutils. And they went actually quite far, and they started upstreaming their changes even earlier than we wanted to start it. So those changes overlap our contribution, but overall we were happy that that work is going, and also after upstreaming those changes to binutils, community started working on GCC. After adding some minimal contribution to GCC, somehow there was not enough interest to continue that work in community, and at that moment we picked up that work and started working also on improving and bringing new target, introducing new target to GCC. So we, on top of that, was introduced by community. We added DLL import export support. Also, we implemented structure exception handling in binutils and GCC. That work was not fully finished, but we decided to also bring support and check that other packages which are based on C are working well. So we pick up OpenBLAS as the most trendy library, one of them, which is needed for machine learning and artificial intelligence. Then we pick up also OpenSSL, well-known library for security communication, also FFmpeg. The choice for FFmpeg was mostly because of complexity of that package, and as a result, it brought us quite a lot of information and issues which we were fixing in GNU Target. And as a library, which was the easiest way to compile on AArch64. So once those packages were green, we were able to build and also test them. It was actually time to start contribution to upstream for GCC, but amount of code was quite big, and we decided to reduce the scope to C. And we decided that first patch series which will go and will introduce new target will be just C language to compile hello world. So we started working on first patch series. We extracted some code which we would like to contribute. As a result, it was around 15 commits in the beginning. And during review, you need to do quite a lot of reshuffle and need to be sure that the quality of patch series is not getting worse, or it's staying the same or getting better. And for that purpose, we developed also CI, and CI was based on GitHub actions. So that CI checks all the time when you're changing something in patch series other targets, because during our work we refactoring quite a lot x64 target and also AArch64 Linux target. So it's checking other targets, and also it checks other packages which we're using for testing. Most of the time you can run CI checks on default GitHub runners, but in some cases, especially for testing, you need to run the executables on real AArch64 device, and for that reason we added our self-host runners to our CI. I believe GitHub Actions will add soon also AArch64 runners, but for now we are using our self-host runners. And later we were using our CI for daily rebasing, which help us a lot also to detect some regression in upstream. So we're checking binutils, GCC, and also MinchW. And there were a couple cases when we were reporting regressions, and usually communities were active and we were getting fixes relatively quick. So CI was quite important part of our journey to prepare good quality patch series. So once we got our patch series ready for review, the next step was to review our patch series with Linaro. Linaro definitely have extensive knowledge and experience in contributing for GNU Toolchain. We were really lucky to work with developers which have 10 plus years of experience of doing this thing. Definitely strong credibility in GNU Toolchain community. So we had 6 more reviews with Linaro. Usually one review was taking like around 1 week. And at the end of that cycle of review with Linaro, our initial patch series, which was looking good for us, was refactored, I would say 89%, and the quality was raised to high level, which can be appreciated by community, and actually it was appreciated by community. So once patch series was ready after we used Linaro, it was submitted to mailing list. As you can see on screenshot, it triggered quite discussion there, and after 3 extra reviews with the community, we got our patch series approved. It was waiting for a while because there was stage for the CC release, and we were waiting when GCC stage 1 will be open. So this patch series introduced new target for GCC, and new target will be supported and tested, and also CI will be extended for new target, and that work will be supported by Linaro also. Regarding our timeline for future contribution, we are going to merge patch series 2. So in May we already merged patch series 1, so new target was already introduced and GCC. We're happy for that. Patch series 2 is also on review with mailing list. We're expecting to merge it this month. Third step for us will be also providing debug information and call stack support and debugger. And during our testing, we detected also some issues with optimizations and GNU Toolchain, so we need to address them also. So we're expecting that it will be material for patch series 3. Also, unit testing should be significantly improved, and especially it will be improved after providing debug information of patch series 3. So for now, it's failing quite often on unit testing because debug information is not there. Also, we would like to contribute C++ support without structure exception handling at least. We need this for Cygwin and for work for enabling POSIX. And maybe also this year we will try to finish our work on structure exception handling for C++ fully, that it will be working fine. So it will be really great to finish it until this contribution window for GCC 15, but we will see how it will be going. So this is shortly about our journey on GNU Toolchain. As I mentioned, there is another stream of work on Cygwin and enabling POSIX, and Radek will provide you more information about that.
Thank you, Evgeny. Hello, I'm Radek Bartoň, and I will try to give you answer to the question why actually port of Cygwin is needed for Git for Windows enablement. Evgeny told you that basically Cygwin or MSYS2 are a dependency of Git for Windows, but actually in, let's say, practical reality, Git for Windows distribution, or let's say installation package, is actually a distribution of over 230 MSYS2 packages. And also the SDK for building the Git for Windows is another distribution of MSYS2 packages. Also, in the MSYS2 environment, or let's say in the MSYS2 package repository, there are several or many packages that are dependent only on the MinGW runtime, while some, especially bash.exe, perl.exe, make.exe, etc., are actually dependent on the POSIX environment, depending on the MSYS2 runtime, which is actually just fork, or let's say it's being built from upstream Cygwin codebase with some minor patches applied. So to enable the full experience, full user experience, including the bash terminal, some Git-related Perl scripts in the Git ecosystem, we need to port also those components depending on the MSYS2 runtime. Small note, you may already know that there is already port of some of the MSYS2 packages. They are in the C-Lang AArch64 environment of MSYS2, and they are built by LLVM for 2-3 years. But those are only dependent on the MinGW. There is missing the parts or the packages that are POSIX related. Here on this diagram you can see where we are currently with our work on enabling MinGW and MSYS2 packages or toolchains inside of the MSYS2 environment. The MinGW toolchain is, let's say, feature complete in the experimental sense. I will tell you on the next slides how you can try it already and give us some feedback about them. And currently we are at the stage where we are assessing what will be needed to port Cygwin to ARM64. We have experimental build of the Cygwin target GCC toolchain. We have managed to build Cygwin or MSYS2 runtime with this toolchain. This toolchain can build, let's say, simple hello world-like applications, but a lot of work will be needed to enable all the features that MSYS2 runtime provides. So inside of the MSYS2 environment or Cygwin toolchain of the MSYS2 environment, we will have to enable or introduce two another targets. I believe the journey will be, let's say, similar as we done or with help of the community we have done on enabling or adding MinGW targets to GCC. Those Cygwin and MSYS2 targets will be necessary to add as well. We are in the stage of identifying what will be the challenges. So far we know that maybe the biggest challenge will be fork or proper fork implementation for Windows ARM64. In x64 it kind of works, but there the high entropy virtual addresses and ILSR is not required, is not mandatory, while on ARM64 this is mandatory. And in certain environments this causes problems. There were made some demos or experiments, but so far they are not conclusive. So we still don't know whether fork implementation with all the environments it needs to run will be possible, or there will be some hiccups that will have to be overcome. Also, a lot of code in Cygwin codebase is implemented in assembly. So, for example, POSIX threads, signal traps are using stack manipulation implemented in assembly. This needs to be ported. Also, there is significant part of Cygwin or MSYS2 runtime, which is actually hybrid library in the sense that it behaves like both like static library and both like dynamic library, and it uses its own code implemented in assembly to load DLL symbols dynamically to emulate the behavior of shared objects on Linux or on POSIX. So those are the biggest challenges we have identified. So this slide shows you how you can already try the MinGW part of the MSYS2 toolchain. We are managing and updating MSYS2 overlay repository with those packages on the GitHub project listed below. So you can add this overlay repository into your pacman-conf, update the database, and install the main GCC compiler toolchain package. It will fetch the dependencies, and since then you can cross-compile the ARM64 binaries on either x64 machine or ARM64 machine in the MSYS2 environment. Please do, if you will find some issues, report it to the link, and we will be very happy to assist you and resolve all the issues with this toolchain. This concludes my part of the talk, and Evgeny will sum it up.
Yeah, thank you, Radek. Thank you for providing us information about where we're standing with the Cygwin and with the POSIX. So we would like to invite you to try our contribution to GNU Toolchain. So here is a link on our repo. So please take a look and try to compile something for Windows ARM64. And please also report if you have any problems. We will try to address them as soon as possible. Here also you can find link to our MSYS2 experiments. And many of the slides which we show today, they deserve separate presentation. So maybe in the future we will include some extra information and other presentations. And I believe that's it. And if you have any questions, we would like to answer them. Okay, it looks, oh, one question from Tiago.
I understood that the driving motivation for the GCC port was to compile Cygwin, since LLVM is used for the other packages. Did you consider adding support for compiling Cygwin with LLVM? Or how hard it would be? I don't know, was that a possibility?
Yeah, I think Radek will be the right person to answer the question. So initially, our idea was to use GNU Toolchain for that, and LLVM. GNU Toolchain is recognized mostly by Cygwin community, and this is actually why we started working on that. And recently, there was some work on bringing LLVM support for Cygwin. There's something else was going there.
Yeah, this option was on the table all the time. We are still in the stage of investigating, like, what's the best way, what's the best option. All the time we have been asking experts on Cygwin or GCC. We've got answer that it's better or easier to port GCC to ARM64 than actually introduce Cygwin port to LLVM. On the other hand, somebody from LLVM community tried it like 2 weeks ago, and he or she managed to build Hello World-like application with Cygwin, for Cygwin with LLVM as well. So he or she is at the same stage as we are with GCC. But as I said in the presentation, this is just beginning. So it might happen that both paths are same complexity or one is better, but we would like to proceed both options.
So initially in the first slide, you kind of mentioned that you were also working on PyTorch support for ARM64. So can you share some status on that? Where are you exactly on that, and how is Meta and others kind of responding to that?
Yeah, Radek, exactly the right person to reply on that. He was working on PyTorch.
Yeah. We are at the stage where we can build either libtorch or PyTorch using MSVC compiler and with, let's say, a minimum set of dependencies. And we are at the stage when we are trying to figure out what will be the best OpenBLAS or BLAS Alapak implementation. We have managed to, let's say, build PyTorch with both OpenBLAS and APL. Both have some issues in the sense that we defined our definition of done as passing all the core PyTorch unit tests, and there are several failures, at least on the OpenBLAS side. Recently, we have managed to resolve all the test failures on the APL side. So far, we don't much care about performance, so certainly some decisions would have to be made which of those two paths is more sustainable from the performance standpoint. And we are like cooperating with Meta infrastructure team who will actually help us to introduce this new target to official upstream pipeline and quality checks.
So would Meta eventually... So would Meta eventually host pre-built binaries, let's say like Python wheels or NuGet packages or whatever, right, for developers to actually use PyTorch on Windows on ARM?
Yes, that's our target. We can promise it, but this is something that we would like to achieve.
Okay, then thank you for joining us today, and have a good rest of the day.